I'm Scott. I'm going to be talking about Azure security today. The goal is for, if you are already doing offensive security, to inspire you to learn about Azure and cloud hacking. And if you're not, then just inspire you to do hacking in general. The goal is learning and fun. So please feel free to ask questions as we go. And I hope you enjoy. Thank you for coming. So a little more of an intro. I'm Scott Miller. I'm a pen tester. I've been pen testing for 6 years. I started at the University of Florida on the InfoSec team. That's how I got into security. Some of my friends from the club are here today. It's great. And then I joined Synopsys out of college and worked as a pen tester there. And now I'm at Accenture. Been at Accenture in Seattle for 4 years. And mostly what I've done is web and mobile and application security, all hacking. I like to stand strongly by the fact that I don't do anything but hack. No defense, no building. I only hack things. So if you want to stand up for what you believe in, always. So generally I do mostly AppSec and I test web apps. However, what's most interesting to me and most exciting is infrastructure. I like attacking people and things, and I've just done so much web hacking, it's not quite as exciting anymore. So I find an outlet in teaching and training and conferences. So I like to learn something totally different from what I'm doing on the job and then teach it at conferences and at schools and trainings. So a few years ago, I did the Abusing Active Directory on-prem in Azure course at Black Hat. Turned the Azure portion into a talk and have built it since then. It's an overview of some attack paths through Azure, the configuration of Azure from a security perspective, and how to approach a pen test on Azure. As I mentioned, I feel very strongly on not building things. So I didn't want to have to build the infrastructure for this. Luckily, Mandiant has an online cloud workshop that has some of these configurations. And so I use that for my demos. So thank you to Mandiant, if anyone's here or not. But afterward, you can go and try these same things that we're talking about today on your own, available for free. So it's great. So thank you. All right, let's get started. So Azure, for those who don't know, it's a cloud computing platform by Microsoft, very similar to cloud computing platforms like AWS and GCP by other providers. You can deploy resources to do things that you want to do. So if you want to store things, if you want to run scripts, if you want to manage infrastructure, etc., you can do that. And they're always adding new services, very flexible. What is interesting about Azure is the integration with Active Directory. So all of the cloud providers, or most of them, have an Active Directory implementation in the cloud. However, Azure's is cool because it integrates with on-premise Active Directory, and most Active Directory implementations are in Windows, and so it makes it more exciting, at least for me, to hack it because you know that there are people there that you're attacking, and that's exciting. So we're going to talk about that. And so keep in mind that we're talking about Azure, and we're also talking about Azure Active Directory, which is known as Entra ID now. And so they work together, but they're not the same thing. So try to keep them separate. And we'll talk about the differences a little bit. Permissions is one strong difference between them. You can be in So generally, the highest level of access in an Azure account is subscription. And so within the subscription, you can have multiple tenants, which are like companies or departments or organizations. And so you can have access within a tenant. You can have access within a subscription. You can have different scopes of access. And it's very important to keep track of what access you have, both if you're trying to configure it correctly, configure it securely, but also if you want to attack it, you need to understand exactly what you have access to so that you can attack those things or investigate those things. So you can be an admin in Azure without being an admin on a tenant. You can be an admin in a tenant without having access to a subscription. Yeah, again, it's important to figure out exactly what you're looking at, and we're going to do that each step. We're going to identify what our access is, our privileges, our roles, and on what scope those apply. I mentioned the services before. You can store things, you can create applications, you can run automation scripts on virtual machines in the cloud. Pretty much anything you want. These are just examples. Cool. So our first scenario, we're going to start assuming initial access. So in this case, we get access to, well, first, storage accounts and blobs. So in Azure, if you want to store stuff, you can store, there's many different types of data you might want to store. If you want to store structured data, there are database implementations. You can store structured data in a database. If you're storing unstructured data, like images or videos, where you can't really put into a database, then you often use blobs, binary large objects. And just basically, you put them there, and they stay there. So the high-level container for storage in Azure is a storage account. And so we're going to look within the storage accounts, see what storage accounts we have access to, and see what blobs or other data is inside of those storage accounts. So we get initial access to a user, Katie, and we want to identify her role, privileges, and storage accounts that she has access to. So first of all, interacting with Azure. Generally, you can do that in multiple ways. You can do that from a browser, which is probably what most of you have done. You go to portal.azure.com, and you can access different information. However, that only shows you certain things. Sometimes you can see things there you can't see through other methods, like this right here, AZ login. I don't know. Hopefully that's big enough. You can. It's the Azure command line interface, and that's a multi-platform tool, which is why I like it. So I mentioned one thing that I don't like. I only like hacking things. Another thing I feel strongly about is disliking Windows. I know I'm talking about Azure, but I don't want to use Windows to hack Azure. I want to use Linux or Mac. So AZ is cross-platform, and so that's the biggest reason I like it. Also, command line is just more fun. So we're going to use the Azure CLI for most of the stuff we're doing today. However, we'll notice sometimes that we'll have problems. Either we're not able to, like some functionality is not available in the CLI, or it's not as easy as it would be in a portal. And so we will use different tools. And there's also PowerShell module that you can use as well. That's what I learned initially. But I think the CLI is much easier and more fun. So first, we log in. It's going to open a browser, and I'm going to log in on the browser. You're not going to see that, but it's going to populate credentials. Cool. So once I've logged in, you can see information about the login session. So you can see the name of the subscription, the ID of the tenant, so that's like the organization, as well as the user and the user type. And so pay attention to the type there. It says user. We're going to see different, I think at least 3 or 4 different types today with different kinds of accounts that we're accessing. So we have the credentials now in the Azure CLI. So we're going to do a role assignment list to list all role assignments to which we have access. And so I'm going to copy Katie's username, and it's going to list all of the roles that she has. So you can see that she is a storage blob data reader. And then you can see the scope right under that. And so it basically starts as a subscription, which I said was the highest level overhang, and then goes down by object to what she has access to. So she has access to that Scott data mining 01 at the end, that's the storage account, and we'll see that shortly. So we're going to list storage accounts, AZ storage account list. And I just mentioned the storage account there. You can see that listed in name. Yeah, sorry, it's fast, but Scott data mining 01. And then we're going to look within the container to list the blobs container. Sorry. We're going to list the containers within the storage account that we just found, that we had access to. And so this is going to list that there's a container called investment within that storage account. And so we're going to look inside that.
I don't know if there's any way you could change from dark to light, but it would make it a lot easier to see the slides.
Dark, I cannot, it's a terminal. But I agree, it's difficult to see. I apologize. Yeah, that might be better. Yeah. And I will share, so there's going to be an overview slide next. We can talk about what happened. And I'll also share the slides. But yeah, I apologize if it's hard to see. Let's see. Better? Cool. Awesome. So let's jump back a second. We can see here we did it. Cool. We did a storage container list. We found the investment container, and then we're running a blob list within the container to see what blobs are in there. And we see that there's one called secret.txt within investment container. So we're going to download the blob. Please disregard any typos as I was typing this. The first time I did this presentation, I did live demos, and it took twice as long because I was making so many typos. So this is the best we're going to get. All right, so then you can see I downloaded it, and I looked at it. I catted the secret file, and it's an RSA private key. Turns out it's a private key, an SSH key that we can use to access one of the virtual machines on the Azure account. So this was in, well, so yeah, let's leave it there for now. All right, and then also showing here in the portal how you can do the same thing. You can go to storage accounts. We see that storage account. We go to storage containers, storage browser to look at the containers, investment container, then we see the file, and we're able to download it there as well. So two alternative ways to do this. So in this case, either would have worked. All right. So we checked our access, the access we have as well as the scope over which that access applied. We checked the storage accounts that existed. We looked at which blobs existed, and we looked inside the blobs. So this is like, we're talking about Azure vulnerabilities. However, in general, most of the vulnerabilities are in configurations because it's very hard to configure. And generally, a lot of cloud environments are hard. Azure is, could be argued is harder than some others, but that just leads to more misconfigurations. So it's important to understand exactly how things are set up and who has access, even if you may assume that it is secured, it may not be. So in this case, the only vulnerability was that the data that we found should not have been where it was. Maybe. Also, maybe Katie shouldn't have access to that in the first place. We don't know. Because we're an attacker, so we don't know exactly why it was there, just that it is. So, but but it's important to think about that as you're going through. All right, so sensitive storage, protecting it is just general techniques. Get rid of data when it's not needed. Don't store private keys in investment containers. Encrypt data at rest and in transit. Implement least privilege. If Katie doesn't need access, she shouldn't have access. And then audit data wherever it is. All right. Virtual machines in Azure can be used for hosting applications, running scripts or workloads, hosting infrastructure. You can set up testing labs or development machines, really whatever you need to do. So I mentioned that key is a virtual machine key. We're going to use the key to access one of the virtual machines in the Azure account. And then we're going to see, we're going to see that Katie has some other permissions that we haven't yet enumerated. So we're going to do a role assignment list again. Okay, and we're going to go up to the top. We're going to see that we have access to a VM NSG, Network Security Group. We also have access to my public IP. So we're going to see what we can do with these. So we're going to list the IPs within the engineering group. And we have access to the public IP. That's why we're able to read it. And we can see that IP address, 0.195. So the reason it's just a public IP, in Azure, if you create a VM and you want to assign it an IP, it's not like attached to that. You can have an IP, public IP, and then you can attach it together, but you won't see it as the VM. They're two objects. That's why we see the IP. So we don't necessarily know what it's for, but it's something that needs to be accessed externally. So we're going to guess that it's a virtual machine. So we're going to try SSHing to it using our private key, secret.txt that we just downloaded. An Azure user is the default user for VMs in Azure. It fails. So we're going to list the network security group rules to see if we're not allowed currently to access that. So again, within the resource group engineering. So I said before we have access to Linux VM NSG. So we're going to read it and see what it says. And it is not outputting. Apologize. If it had outputted, it would have shown that we did not have access currently. But we have access to that network security group, so we're going to create a rule for ourselves. We're going to set our host IP address that we're on, as well as the endpoint that we're trying to access, and add a rule so that we can access this virtual machine. Okay, so it added, you can see it succeeded, and it was added as ScotNet rule under the virtual machine network security group. And now we're changing the permissions of the key, because you need to do that whenever you create an SSH key or create a file to use as an SSH key. So that's me looking up the permissions. And then we are able to connect. And so now we're on the virtual machine within the Azure account. So we checked our access. She was a VM IP reader, Katie, and also an NSG, Network Security Group editor. We read the IP and tried to access it, but we didn't have permissions because of a Network Security Group rule. We updated the access policy, added our Azure IP, and then we used the SSH key to connect. And then we're going to enumerate the virtual machine and try to escalate further. Was there any vulnerability here other than what we talked about before, the SSH key being in the wrong place?
Yeah, she had access to it. She was.
Correct. We again don't really know it seems like she shouldn't have access to read data in investment accounts and also edit network security group rules. That's probably a misconfiguration. Anything else?
Accessing that IP from anywhere. There's no firewall on Azure that lets you to access from any source IP address.
Right. I guess if you need to access the virtual machine, it might be a administrative machine. The network security group would block it. So, but yes, it could be further secured.
And the default, well, just using the default Azure username and not changing the default.
Yeah. If you change the username, it would take me a little bit longer to guess it. But
Even with additional, misconfigurations like using the chmod, changing the permissions, right? Like that, like a potential misconfiguration of that user profile, allowing cadence to change permissions and then escalate further. Not so much vulnerability, but more so of a misconfiguration issue or a privilege issue. In this case, right?
so it's just Linux just enforces that the SSH key is secured before you use it to access. So that was not a configuration on the Azure side. But yeah, so again, one clear issue, but you're unclear, and we're going to see this is a pattern, unclear whether or not it was misconfigured. It's all, it's about the enterprise that you're attacking, whether they meant to do that or not, and you don't know. So protecting VMs and SSH keys. Don't put your SSH keys on Azure. Don't put them on Twitter or in QR codes. And make sure that that SSH keys are being used. This is something you can audit and should be auditing to make sure they're being used reasonably and by people that you expect to use them. So the only people who need to manage this Linux VM should even have access to it, and that can be tightly enforced. It shouldn't be broadly accessible. So now just the summary of the scenario. Someone added a private key to Azure, probably to access it somewhere else, access it from home, whatever. And we were able to get it. We got access to Katie's account. We were able to connect to the VM because she had misconfigured permissions. And we were able to see the public IP, add a network security group rule, and access that virtual machine. Okay, so managed identities. When you create an object in Azure, you need it to have an identity. So basically, everything in a tenant needs to have an identity. That way, it can authenticate to other services, to other accounts. That way, it knows who it is and what permissions it has. So if you want to add permissions, you need an identity. In Azure, you can have managed identities that are tied to an object. And that way, again, you can add permissions to them. If you delete an object that has a managed identity, then the object and the identity are deleted. You can also create identities separately that you can attach to objects, and then they are not deleted together. So that's helpful if you're going to be changing objects often. However, if you leave leave an identity unattached and think it's going to be deleted and then it's not, that can still be used to access the same permissions even if the object's deleted. So it's important to understand exactly what you're creating and how long it's going to last. In a managed identity, the credentials are rotated automatically by Microsoft, which is helpful. So if you can do a managed identity, it's reasonably without too much effort or too much having an issue by deleting objects, then you probably should. Okay, so we're going to see what the Linux VM permissions are. And I mentioned before that we saw Katie was a user. The VM is not a user, but it still has an identity. So we're going to see a difference there. And we're going to try to escalate using those permissions. So we're going to grab the ID. Okay, so I did an AZ login identity. That is, if we have a managed identity, that's how we log in. through the command line interface for Azure. And so we're going to see at the bottom here that it's a MSI, managed service identity, and system assigned identity, service principal. So service principal means that this service, the Linux VM, it has an identity, and that's basically what it's describing. So we're going to enumerate those permissions. Before, we just put the username for Katie. So we're going to try that again, assignee, and put that. But because that's not really meaningful, it's not actually attached to that, we're going to get an error. And one thing to call out here, and we're going to see this later, Microsoft has an Azure have a graph API. And basically what the CLI is doing is it's just calling the graph API in the backend. So it's just a front end for the graph API. But anything you want to do, you can do by hitting the graph API directly. So you'll see here, the error is related to the graph database. So that's because it's calling the graph API. So we're going to try a different thing. We're going to get an access token to use to hit the API directly. Okay, so this is a token that we're going to use with a curl command to hit it directly and get what roles we have currently. So we're setting a bearer token to this value we just got, setting it to the endpoint, management.azure.com. We're putting the subscription ID to say what subscription we want to access, and we're hitting the API /role assignments to check what role assignments we have. Okay, so we can see we have this role that's unclear. We can see the scope. The scope is over a Windows VM. So we know there's a Windows VM. And something to mention here is this Windows VM, we only saw one IP, right? So it's not accessible externally. This is only accessible with this identity from Linux. So we're going to see what kind of, we don't know exactly what that role is. But we're going to see, we know we have some access to the Windows VM. We're going to try to just connect to it. So we're going to list virtual machines. And we can see there's a Windows 10 machine that we have access to. So we're going to try to run a command on that Windows VM using the Azure CLI. And we're going to run a PowerShell script. On the Windows VM in resource group engineering. And we're going to put in the scripts parameter, our command. So I'm going to add a user, net user Scott, with a password. So that's going to add a user to the Windows VM. As usual, very slow, Windows. But it will complete. Okay, provisioning succeeded. So now we have a new user. And then we're going to add that user to the administrators group, and then we're an administrator on the Windows machine. So adding Scott to local group administrators. And that succeeds as well. Cool. So that, we went from data reader, we got a SSH key, we SSH'd to the Windows, to the Linux VM after configuring the network security group, and then we used the graph API directly to get our roles. We were able to get the VMs, get access to the Windows VM, and run a PowerShell script upgrading that user to administrators.
What if there was no was an orphan managed identity, and is there anything you can leverage a managed identity if there's no instance attached to it?
Yes. So if the question was if there's a managed identity that wasn't attached to this VM, it just had a managed identity. If we had access to it, we could log in as that user and access anything that it had permissions to access, whether or not it has an object attached to it. Any other questions right now? Was there further vulnerability here that we saw? Yeah, we don't know if the Linux VM, probably the Linux VM shouldn't have access to administer the Windows VM. Probably should be independent, but again we don't know. So, but it's fine. Cool. So protecting managed identities. Want to limit permissions where you can. Audit sensitive permission use, for example, adding users. And adding them to administrators. Generally, so I'm a pen tester, not a red teamer, but red teamers feel very strongly don't add users. It's very obvious. Don't upgrade to administrators. It's very easy to keep track of that. So there are other ways to do this. This is just a very simple way to show it. But to achieve persistence, yeah. So still do your best to audit. There's almost always going to be a way to find out what an attacker is doing. All right, next scenario. So we're going to assume, again, initial access from a different vector. So app registrations. In Azure, app registration, when you create an application, you can register it, and again, it creates an identity for it. That way, that application can authenticate within Active Directory, within Enter ID. You can create applications. You can create cloud applications, web APIs, enterprise apps, and service principals. We talked about some of those before. You establish a trust relationship, which is what you're doing with any identity within the Active Directory account. You're saying what's supported, what permissions there are, what it can access, and all that stuff. So this time, we get access to a user, Chris Green, and we're going to enumerate again. So same kind of thing. We're going to see something different here. So first, we're going to try to log in. And I'm going to log in with Chris Green's credentials that I got. However, it says no subscriptions found. So I mentioned at the beginning that you can have access to a subscription or a tenant. So in this case, Chris is only a tenant level account. So you cannot access the subscription. We can't log in the normal way. We can log in with allow no subscriptions. And then it says NA tenant level account. However, when we try to do a role assignment list, it does not work. So when this API, it queries the subscription to which we don't have access. So we need to find a different way to query it. So in this case, we're just going to go to the browser and log in there. So you can go to the tenant and the roles, and you can see here, I'm an application administrator, and you can get a description of it by clicking on it. So you can see it allows you to manage identities. And it also says it's an administrator, or it's a privileged, thank you, privileged account. So anything where you can create identities is privileged. And so we're going to see how we do that here. So we're going to go to applications, app registrations that we talked about before. We're going to click on the application that already exists. We're going to go to certificates and accounts, and we're going to create one. That way we're able to log in as that identity. And we're also going to note the tenant ID and other information that we're going to use to log in as this application identity. So we checked access. We enumerated the applications after we saw that he was an application admin, and we generated credentials to use to log in. Does anyone think that there was a vulnerability in being able to generate credentials as an app administrator? Yeah, I don't think so. However, someone who creates an app or assigns someone, tells someone on their team create an app and gives them permission to do so, may not realize that that means that they can then authenticate an Active Directory as an app. So again, it's important to understand exactly what permission you're giving or have. Service principals are created when you create an application, which gives it permissions. If we have administrative access to an application, we can generate credentials for it and then use the credentials of that app. So Chris doesn't have access to what the application has. They're different, but he has access to that app, so he can generate credentials and then log in as that app. So each thing is a different identity with different permissions, and that's important to keep in mind. So we're going to log in as a service principal through the command line interface and see what permissions we have. So we're listing the app. So again, we did this through the portal. We're going to do it here. We're going to do a credential reset, which is going to create new credentials for this application. So we have an app ID, password, and the tenant ID, all listed here. So we're going to log in as a service principal with the user of the app, the password listed there, and then the tenant ID. And so you can see the type is going to be service principal, which is again different from what we saw the last two times. And the tenant that we're attached to, and the ID of the subscription. Now we're going to do another role assignment list with this index, or this the ID, and we can see what we have access to is we have access to a key vault. So you can see Scott Innovation Key Vault. And you can see that we're a Key Vault secrets user and a Key Vault reader. So next we're going to enumerate the key vaults. So first, we generated service principal credentials. We logged in as a service principal. We checked our access with that service principal. Was there a vulnerability here? I don't think so. The service principal is there. Maybe we don't know if it has access to. It should have access to key vaults. Application, probably it might need a key to use for signing, or we don't know. Against implementation. So, but you can restrict access within that if you want to. Protecting service principals. You should assume that any role that you have in an application can be used by an application administrator. So make sure that those are applied securely and intentionally. Make sure the permissions that are on objects are audited, on service principals are audited and are acceptable. Make sure that least privilege is implemented, and if you want certain conditional access policies to exist, like you can only certain users can access this, or certain conditions they can access these service principals, you can consider implementing those, but they can be bypassed. Okay, key vaults, that's our next step. Key vaults, service provided by Microsoft to securely store keys, secrets, certificates. You can store API keys, you can store certificates, tokens. You can manage keys, it manages keys for you, it can rotate them for you, encryption keys, etc. So if you get access to the key vault, you want to look at it if you're an attacker. They often hold secrets and sometimes credentials. We're going to see what's in the key vault. So we're listing key vaults first, AZ key vault list. There's one here called Scott Innovation Key Vault. We're going to list the secrets within that key vault. We're going to see that there's one called 4PW within that, and that's the ID of the key vault. And then we're going to show the secret. So we don't know what that is. So we're going to write that down. It says 4PW. It's probably for somebody. So someone left a note there, and we're going to see what we can do with that. We logged in as a service principal. We checked access and saw that we were a key vault reader. We listed the key vaults and enumerated the secrets. Now, vulnerability-wise, that doesn't seem like it's not like an app secret that should be used. It's not a managed credential. It's just text. It looks like a password. So it probably shouldn't have been there. Misconfigured. It was misplaced. And maybe like the application probably didn't need access to this secret specifically, maybe not even this key vault. So it could have been further restricted for sure. Protecting key vaults, restrict access to only the secrets and vaults that are necessary. Don't leave messages for other people in key vaults. And audit key vault access. Don't let people access the key vault network, unless they need to. Okay, and next we're going to talk about conditional access policies. So you can use these to set conditions for how a user can log in. So, for example, if you have a developer that is based in the Netherlands and should only work from the Netherlands, you can say that allow access only if this user is accessing from an IP in the Netherlands. You can require multi-factor authentication to log in, but only in certain cases, so conditional. So you can say, if this user is on-site, don't require multi-factor, or within a secured network, don't, but if they are external, then do. So there's lots of conditions you can set. One thing to note is if you want to set conditional access policies, you need to disable the default security that Microsoft sets, which if you can duplicate them all, but you need to make sure that you have equal security once you turn them off. So don't just turn it off and then start up conditional access policies one by one. Do it all or nothing. I mentioned IP or region. You can allow log in from a certain type of device. So only a phone, only a computer, Linux computer, etc. Okay, so we're going to see that we are not able to log in because of a conditional access policy, and we're going to try to bypass it. So I'm actually going to do half this video, jump to the other, and then go back. So we're going to go to the portal to try to use, well, first we're going to enumerate the users to see if there's a user PW. And there is a Peter Williams. So we're going to assume or guess that 4PW is for Peter and see if we can use this password to log into his account. So I enter the password incorrectly first, then I enter it correctly. And it says I can't access it right now. And it says the sign-in was successful, but it doesn't meet the requirements to log in. So that tells us that there's a conditional access policy in place that we need to bypass. So this tool called MFA Sweep can be used to check different user agents and see if any of them bypasses MFA. Or bypasses, or is able to log in, basically. Bypasses the condition. So we're going to try it. We're going to authenticate with the Graph API, the Service Management API, the portal, mobile user agent, etc. Lots of different user agents. There's some bugs in this app, or there were. And so what it says is that we can authenticate with the Graph API, Service Management API, but nothing else. This is incorrect. There was a bug. It may have been fixed by now, but we'll see that we are able to access it with a Linux user agent, even though it doesn't appear so. But we could. So I talked about before. You can access something in the portal sometimes, or sometimes it's easier in the CLI. You could even have permissions that'll only allow one or the other. So it's important to be able to use Azure from different interfaces. Okay, so let's go back here. We're going to reload. We're going to go to the DevTools, and we're going to create a user agent for Linux. And I've already done that here. And you can see I just copied and pasted from my Linux machine, or I looked up Linux user agent. I'm going to reload. And so sometimes this doesn't work very well, and you'll see it will fail the first time. So I'm going to open a new tab, try again. Do the same thing. Reload, and then it works. So now I'm logged in as Peter. So I was able to bypass the conditional access policy by using a Linux user agent to make it think that I am on Linux. And now I'm able to do everything that Peter can do. So we identified who the cred was for in the key vault. We tried to log in as Peter, it didn't work. We tried to we enumerated using MFA sweep to see what user agents would work. We changed the user agent in DevTools and we logged in. Now here was their vulnerability. Yeah.
Do you think setting the condition as user agent Linux is something too vague that can be easily bypassed?
Absolutely, yeah. Setting the conditional access policy to Linux is not reasonable, and you can, like I guess if you do that and you're non-technical, you might assume it's going to enforce it, right? So you have to really understand if you're going to do a condition, you need to understand exactly how it's checking for that condition. But anything that is checking what a user is using is going to be user controlled. I can tell you I'm accessing anything with anything. So make sure that your conditions are reasonable, and so that's definitely an unreasonable condition to set. You can pretend you're on certain IPs, certain Macs. Anything really can be changed. So the vulnerability here, the misconfiguration, is probably just a misunderstanding of if I say this, is that really going to be enforced? But also, I mean, I could just pull out a Linux laptop and use it too if I didn't want to do this. So yeah, they need to be intentional conditions that make sense. Conditional access policies are always bypassable. The most common one that seems to have come up a lot is only require MFA, in certain scenarios, and then you just go outside of those scenarios and you bypass MFA. Generally, just the less you can have conditions, just require security in all cases, the better you're going to be. That is all the demos. These are some of my favorite tools. I think it's something that I talked about. MFA Sweep, we saw. Scout Suite is just like generally a pen testing tool we use to find issues in cloud environments, and then we can enumerate further. Azure Hound. So Bloodhound is an Active Directory enumerator and path mapper. But there's a collector for Azure where you can give it information or have it go through Azure, find different privileges, and then see how you can get to an admin or escalate through the network. O365 Recon, enumerate Azure, find resources and privileges, and then this lab, as well as lots of other cloud labs, are on that GitHub link there. There's a lot. It's really cool. For AWS, Azure, and GCP, and some are self-hosted, some are already hosted elsewhere, so they're great. Any questions? Any questions? Yeah.
When you talked about the way to enumerate the accounts, right, in case of the guest account, this is only because there exists a vulnerability in multi-factor authentication of what not the agent, right? Choosing the right agent in case Linux, right? When you talked about how by checking the agent you could gain access, go to conditional access, right? But in case if the entity uses an external provider, like the external multi-factor authentication or like the in-house proprietary two-factor MFA solution, that can be avoided.
Can you clarify? Sorry.
So say for example, in the case we showed the whole thing with the Peter account, right, where you were able to use conditional access and use the Linux to bypass the MFA, right? In case if the provider or if whoever was the user of the Azure tenant had their own service provider, like their own ID provider, right, their own in-house ID provider, or maybe like an external multi-factor authentication like Okta or whatnot tools. In that case, that vulnerability could be completely avoided.
So you're asking if it uses a different tool to log in, a different MFA tool. So all this is doing is authenticating. I mean, you could configure it. It's just a script, right? I could configure it to hit any endpoint with any user agent with any setup. So really, that wouldn't, no matter, if the condition exists that you can log in on any of these, you could do that with any identity provider. So, yeah. Any other questions? Yeah.
Just to clarify, the first example of the block storage, that was assumed reach, right? Before you got there?
Correct, yeah. All of this was assumed reach. assuming we got credentials. Generally, it's very easy to get initial credentials. A lot of people use weak passwords.
Do like pepper spray or like spray to get it to the
Yeah, there's several password spraying tools. I don't think we use either of those, but any will work. Generally, I'll do like 1 week password on all the accounts. Yeah.
that normal way to like usually get into
Yeah. So you can enumerate valid 365 accounts very easily with a public API. Once you find accounts, you can spray them with bad passwords, and you'll find a lot of success with that. Yeah. I'm gonna say, please come up for any further questions. Thank you so much. I appreciate it. Thanks for coming.